Hi, I'm the Rick in Rick Turns, and this is the sixth and the final video in my series of videos about how to make this tool rest for my wood turning lathe. Today, we finally get to the good stuff, silver brazing. We're going to play with fire today. Well, here are the three pieces for the tool rest that I'm making. Now, an astute observer of these series of videos will notice, wow, he must have been feeding his tool post mineral water because it's grown more than twice the length it used to be. Well, what has happened since the last video is I got a new lathe, and it has a 20-inch swing instead of a 14-inch swing, so that changed the length of the tool post that I needed. And I didn't want to waste the gas and all of making the original shorter tool post that I couldn't use, so I went ahead, cut a new tool post, put the hole in the end and tapped it. I wanted a shorter tool rest for this particular lathe because it came with a 12 or 14 inch, something like that. So this is about an 8 inch, I think. Now other than that, everything's been prepared the same. I've already took a flat disc on my angle grinder and cleaned this off. This of course has been cut and drilled. This is ready to go, and that's my screw to fasten them together with. Now before you actually attach the post and the arm there, what you should probably do is just take it and get a square and hold it like that. See if I can get that down so it'll show on the camera. Yes. Get a square, hold it just like that, and check it all the way around, because it's quite possible that you've got one area that's going to be a little bit straighter than others, or maybe one area that is not quite square all the way across. So find your best location for squareness, and if they're all equal, great, you did a good job. But find your best location and then mark it on here. And you see what I've done here. Probably doesn't show real well, but I've got a mark right across there. That is my best location. I was not able to turn this on the lathe because I had not gotten the new lathe set up and the old lathe was already taken down. So I kind of did it by hand on a grinder and the file and so forth. Anyway, right across here is my best squareness. So, next thing to do is clean these joints. Two things that are really necessary for doing silver brazing or brazing of any sort is to have a smooth, well-fitting joint. Hopefully we've already accomplished that with things that I've showed you already. And secondly, to get the joint really clean. I'm using my super duper all-purpose cleaner there. And just going to clean these areas. Now this is the bottom of the tool arm right here. It's going to attach just like that. We'll see that in just a moment. I'm just going to clean that off. And for the tool post, the wear strip, I haven't done much with it. So I'm just going to take a piece of sandpaper, I think this is 120 grit, and just clean it off a little bit. Get it ready for brazing as well. Well, I bet at this point you think we're ready to screw this into this. And we almost are. Normally, I would probably screw those right together and take it over and start brazing on it. And guess what? I have forgotten to put on the flux. I'll tell you, about 9 times out of 10, I forget to put the flux on this thing. The flux is needed to keep the parts from oxidizing while they're heating up. So I'm just going to put some on there. It doesn't have to be real thick or anything, but it just needs to cover all of it. And then I'm going to put some on the arm. Now, let's find my mark on here. Yes, okay, so I want to put this. Here's my mark. Put this right through here. And this happens to be a Phillips head. All right, I'm going to check it for square here. And that looks quite good. Okay. So this guy is ready to be brazed. And now we're going to go over to my brazing station, which is like the middle of the garage. We're going to do the brazing. Okay, I'm sitting in the middle of my garage. There's clear concrete all around me for about 5 to 6 feet at least. I've got my machinist's vise mounted on a log there so I can move it around when I'm doing these tool rests that I'm making. This is the oxy-mapp torch right here, one I'll be using. I made a little case for it just to keep the bottles out of the way. And then this is a strip of the brazing filler, the silver brazing filler wire that I'll be using. We won't put that on until the metal comes up to temperature. Now let me just mention once again, you want to be safe when you're doing this. You want to be careful when you're doing this. Don't do it around anything flammable, particularly if you've got a lot of shavings in your workshop. If you don't have a machinist vise that you can use, or some type of metal vise, I would suggest not to do it with your woodworking vise, which is probably attached to your workbench. In your workshop, which might be a little bit cluttered around the workbench, maybe there's some shavings on the floor, there's an easy alternative. Just use a couple of bricks. These are just a couple of landscaping bricks that I got from Home Depot. Just set them up like that on outside, anywhere. And it holds it nice and level for you. You're ready to go. One thing I might mention with a torch, the manufacturer's got a very good video on YouTube. Search for Worthington oxy-mapp torch, something along those lines. Find the one from the manufacturer. It's a fairly brief video, maybe 10 minutes. Tells exactly how to start the flame, how to stop the flame, how to adjust the flame for the things that you're doing. So I'm not going to cover all of that here, other than very briefly, but really take a look at that video. It's much better than probably anything that I can do. Alright, this is a sparker used to start the flame with. I'm going to just crack open the oxygen valve. And that's just cracking it open. So that's about where we want it to be to start. And now I'm going to add some oxygen to it. The oxygen adjustment is pretty hard to get right. It's just very, very easy to blow the flame out when you're turning on the oxygen. Extremely easy. So I open it about 4 half turns and then go maybe an 1/8 of a turn at a time until I get it lit like this. So that's what they call a starting flame. Then I'm going to add some more MAP gas and add some more oxygen. And that's where I want to get to right there. About a 1/2 inch flame. And now it's a matter of waiting. Now you want to hold a flame where the tip of that inner blue cone is right at the workpiece that you're heating. And we're going to heat this until both the post and the metal on the arm underneath the post are glowing red. There's no point in trying to put on the filler before that metal is really glowing. What will happen is the filler will probably melt if you hold it in the flame, but it will just bead up. It won't get sucked into the joint. When the heat is correct, and you melt that filler right at the joint there, it's going to immediately disappear because it gets sucked inside the joint by capillary reaction. While it's heating up, I'm going to show you what happens when you put in some filler and the metal's not hot enough. I'm going to stick this right in the flame so it'll melt. You can see it right there. See that little silver glob? Now that's what happens if your metal's not hot enough. It'll just stay as a little bubble like that, and it won't go away. You want to point that flame at either the post or the arm, but not directly at the joint. You don't want to burn up the flux. The bottom of the post there is starting to glow red. So I want to get the arm right around it to glow in red too. Alright, let's see if we got anything here that'll melt. Nope, probably not yet. Nope. Actually, yes, that did get sucked in. Let's take a look now, see if we can get some more braze on there. Not yet. We've got good brazing going on now. The filler material is seeping into the joint very well. Almost got it done all the way around. So I'm going to call that done. Turn off the oxygen first. And then the map gas. In my previous video, one of the viewers wrote in and said, hot metal looks just like cool metal. It's exactly the case here. If I were to grab that to pick it up, burn my hand off. Obviously you can tell down here it's still pretty hot. It's got a lot of discoloration there and some bluing there and so forth. Typically I'll either leave it like this or I'll take it outside, set it on the driveway and let it cool off out there. This is going to take at least 30 minutes to cool off. Now the metal's still hot. I decided to proceed with brazing on the wear strip before I do the final test. And I'm going to do that just by fastening it on with a couple of wires. And of course we want it nice and even on both sides. I want these as tight as I can get them without breaking the wire, which is always annoying. Then you have to put on the wire again, and guess what? I didn't put on the flux. I knew it. I always do that. But this time I'm going to put on the flux. Even more embarrassing if I got it halfway brazed on and realized I didn't have flux on there. Now obviously the flux does not need to go all around the bearing strip here because it's only going to be touching in one place. So I just put it all on one strip there and put it right there. Get my wire. Alright, still a little hot, but it's actually not too bad. So, just about ready to heat. I want to make sure that's square in the center there, and then I'm going to move it. I'm ready to braze the wear strip in place now. All right, got to get the torch lit here. I'll normally start doing the brazing at the center, because once it gets tacked in place, then that holds it fairly well for the rest of it. Just like brazing the post on, we've got to get both the wear strip and the arm up to temperature. Both of them need to be glowing red before that brazing filler will flow into the joint and really seal it. And the wear strip is turning red. All right, looks like it might be hot enough now. And if I could just get it onto the joint. Yeah, it's flowing down into the joint now. That's good. Now I'm going to move out to the end here. And as I've said before, I usually only braze a wear strip in 3, maybe 4 places. That spot looks pretty good, and I'm going to move down to this end. All right, that's good. It's sucked into the joint in several places there, and that's good enough. So I'm going to shut this off, oxygen first, and then the MAPP gas. And put the torch down on the concrete, where it usually doesn't get hot, but just in case. So I am going to let this cool off, and I will be back in 30 minutes or so. Ready for the big test. 3 or 4 pound sledgehammer. Nope, 2.5 pound sledgehammer. Just going to hit it right up here. See if it stays in place. And it did. I'm ready to clean this up after the brazing is all done. I've already done a little work on it, you can probably tell. And I'm using my angle grinder again. This is a 60 grit flap disc on here. And it's basically just going to sand it and abrade it right away. And the main thing I'm interested in is cleaning up the joint right here, getting rid of some of the burning marks and some of the extra filler material that didn't get into the joint. Now I'm not going to remove all the gray surface off of the angle iron there. I don't know if that's a coating that the manufacturer puts on it or if it's just a little bit of oxidation after it was made, but it doesn't bother me having it there. You can, if you want to, take the whole thing down to bare metal to a nice shine. Looks really good when you do that. So for this piece here, I've already ground down the bolt head that held this in place. As I said, it's not structural. There's no reason to leave that piece of bolt there at all. So I'm going to clamp this up, get rid of that a little bit, clean it up a little. Now remember, this is going to be hot after you do this, put this abrasive on it, but it's only warm. Just be careful with it. And I think that's got it. I've already cleaned the tool post quite a bit, doing the same thing with it clamped like this and going up and down and around. It's tedious, but it eventually cleans it up, and also it'll make it run a little smoother in the banjo on the lathe. So let's take it over to the lathe and check it out. I'm back at my lathe. This is the new tool rest, so it fits in there. And what I'm going to do now, I'm going to raise it up and just compare it to center line. Get it right about there and bring it up a little bit right there. All right, so that's a tool rest set at dead center line. Okay, that's fine, but I was pretty much sure that would be okay. Maximum height. Well, that's plenty maximum height. I doubt that I'll ever go that high. Minimum height. Looks like I've got about 3/4 of an inch, maybe an inch below center line when this is down as far as it'll go and hitting the ways of the bed. It's a little lower than I expected when it's right there. When I measured for it and I added in my slop factor, I was figuring I'd be a 1/2 inch below center line, and maybe even less than a 1/2 inch below center line, and I'd have to cut some off of the post to accommodate. But it turned out just right. So there's another reason for adding that fudge factor in when you're getting ready to cut the length of a piece. Well, that concludes my series of videos on making a tool rest. This is the one I just finished. I am quite pleased with it. It turned out very well. It turned out different than what I started with, because when I started making these videos, I was making a tool rest for a 14-inch swing lathe. After video number 5, I got a new lathe, got rid of my old lathe, and now I'm working with a 20-inch swing. So the tool post, quite a bit longer than what I had started with. But it turned out well, and I hope if you decide to make one of these yourself, that you'll have as much fun with it as I have.